Yeah.
So now we are going to start with the proportionate method. What is the meaning of proportionate method? Basically, the percentage method can also be converted into the proportionate method. Now putting the values in 1, 2, 3, and 4 formula like that, and in percentage. After that, we'll get percentage. Let's see how. Delta Q by Q into 100. See, elasticity of demand is equal to Q by delta P upon P into 100 is equal to Q by. So it's a numerical formula only, right? It's a numerical formula. Just keep in mind only. So let's understand with the numerical problem how it works, right? So calculate price elasticity of demand if demand increases from 4 units to 5 units due to fall in the price from 10 to 8. Now we can calculate in the numerical form. So what is the meaning of elasticity of demand? Elasticity of demand is equal to uh, so now percentage change in quantity demanded. So change in quantity divided by initial quantity into 100. Let's see how it works. So five, change in quantity. 5 minus 4, it's a change, right? 5 minus 4, it's a change of 1 rupees. Divided by initial quantity. What was the initial quantity? Your initial quantity, price from 10 to 8, right?
Yeah.
Initial price was, 10 to 8. So now initial price is equal to how we can write 8 minus your initial price was 8, right? 8
Yeah.
minus
And
10 upon your present price into 100. It means 20%, minus 20%. Otherwise, initial quantity was, wait. 4 to 5 and initial. Okay. Now look at here. Change in quantity, it means 5 minus 4 and your initial quantity was 4. So 5 minus 4 upon 4 into 100, it comes 25%. Got it? Now, it was a formula related to the quantity. So we have taken quantity. Now, second formula is having percentage change in price. So now we can come to the percentage change in the price. Now, change in price 8 minus 10. Initial price was 10 into 100 is equal to minus 20%. So now elasticity of demand is equal to 25 by 20 is equal to minus 1.25. It's your answer. So this is the numerical calculation of elasticity of demand. So I think so at the end of chapter you need to calculate all these calculations.
yeah.
Again, when price rises from 8 to 10, the demand fall from 5 to 4 units. Now calculate price elasticity demand. First of all, you need to calculate formula. What is the formula of elasticity of demand? This is the formula. So you need to calculate quantity, right? Change in quantity
Yeah.
demanded divided by initial quantity into 100, it comes your quantity demanded. Now after that, you need to change in price. We are going to calculate one by one calculation of ED. What is the formula of ED? Percentage change in quantity demanded. We are going to take figure from this formula. And percentage change in price, we are going to calculate with the self formula.
Okay.
And after this calculation, we are putting these figures in the formula. 20 by 25 into 100. Right? Got it? How to calculate? Got it? How to calculate?
Yeah.
So some important points are there. Uh, Now always consider the absolute values. Elasticity should always be measured and compared in absolute terms only. Absolute terms, it means what? Ignoring the negative sign. You need to ignore the negative sign like this. Got it? So not in
Yeah.
algebraic terms. So elasticity of demand of 1.25 in the illustration 1 is taken to the higher than 0.8 in the second illustration, etc. Right? So these are the explanation. Now elasticity is affected by percentage change. Price elasticity of demand is not affected by absolute change in demand or price. Rather, its value is influenced by the percentage change in the its price. Let's say understand how to understand. In the both illustrations, this one and this one, right? Change in quantity demanded in 1 units, right? And change in price to is same like this, 10 rupees first of all and then 8, and this is the figure. So, however, the price in the elasticity in the first illustration is 1.25 negative, and different from the in the second illustration is 0.8. This happened because in the illustration one, so demand changed by 25% and price changed by 20%, whereas the second illustration demand is 20% by and 25%. Vice versa. Just you need to keep in mind, ignore the negative signs only when you are going to calculate the elasticity of demand. So again, the coefficient of price elasticity of demand is pure number and independent of a price and quantity units. It means elasticity is not affected whether the quantity demanded is measured in kilograms or tons. Elasticity is not affected. But when you're measuring and the in kilograms, either tons, either rupees or dollars,
Yeah.
it related only commodity only. It happened because elasticity considers the percentage change in the price and commodity of demanded. Because elasticity of demand is related to the quantity demanded and price only.
Mm.
So we can easily compare the price sensitivity and the inexpensive goods like needle and the expensiveness of goods like gold, etc. So these are the important explanations about this. Now, what is the relationship between the price elasticity of demand and the total expenditure? Now, this is a different concept that is called as total expenditure. So, price elasticity of demand for good and the total expenditure made on the good are greatly related to each other. Basically, demand for a good and expenditure on that good, that is called as total expenditure. When we talk about the goods, then at the same time you need to consider price also, that is called as expenditure also. At that times, it becomes important to determine in the effect on the expenditure on good due to change in price of good. We are going to expend on that particular amount on particular commodity, but when we are going to think about that when changes happen in the price of the good, right? Huh. So we know that price of good and the demand for the good are inversely related to each other, right? Both are inversely. So a responsiveness of demand in relation to change in the price determine the change in expenditure, right?
Yeah.
Now let's see again. Elasticity is more than one, that is called as ED more than one. How? When demand is elastic, a fall in the price of commodity results in the increase in total expenditure on it. But on the other hand, when price increases, total expenditure decreases. When price increases, total expenditure decreases. It means in case highly elastic demand, price and total expenditure move to the in the opposite directions. Simple term. If you know understood the definition of the demand, then elasticity of demand also remains same. There is no change because see when price increases, demand decreases. Instead of demand decreases, you can write down total demand expenditure is decreases. Got it? When
Yeah.
price decreases, total expenditure increases. Got it?
Yeah.
Now we will understand, with better understanding on this table. When price of X commodity was 5, we purchased 100 quantity. Total expenditure was 500. Right?
Yeah.
It means what? When price of the commodity is increased, right? Quantity for the demand is decreased. When price fall down from 5 to 4, quantity demand will be increases. Got it? So total
Yeah.
expenditure also increases from 500 to 560. Got it? That is why ED is greater than 1 because total expenditure rises with fall in the prices. Total expenditure is increasing when prices fall down. Got it? Total
Yeah.
expenditure increases when price fall down. That is why it is called as ED is greater than 1 because total expenditure rises with fall in the price of the commodity. Either good. Now, in the other situation, vice versa, elasticity is less than 1 because because a fall in the price of commodity, a fall in the price of commodity leads to fall in the total expenditure. Leads to fall in the total expenditure. In the other hand, when price increases, total expenditure also increases. Right? It means in the
Yeah.
case of less elastic demand, price and total expenditure move in the same direction. Let's say understand on the basis of this numerical. When the price was 500, we bought 100 units and total expenditure was 500. When price fall down, quantity increased from 100 to 120, but total expenditure decreases. Why? Because our heading is that elasticity is less than 1. It means what? ED is less than 1. Right? Your elasticity is less than 1 because of the reason when price was fall down, quantity is increasing, but total expenditure was decreasing. This is the another situation. This is another
Yeah.
situation. Now, what is the third situation? Elasticity is equal to 1. ED is equal to 1. How? When demand is unitary elastic, that is a fall or rise in the price of the commodity does not change in the total expenditure. It means when price was 5, we bought 100 units, but your total expenditure was remained same. When price fall down from 5 to 4, quantity increased from 100 to 125, but your total expenditure remains same. That is why it is called as ED is equal to 1. Got it?
Yeah.
See, all these, tables, explain in that, diagrammatical formats only, right? Just you
Yeah.
need to keep in mind, mind three important points and tables. But some drawbacks are there. Let's see what are the drawbacks are there. Total expenditure methods suffer from one defect. Which one? It fails to give the exact magnitude elasticity. It's not going to exact, magnitude elasticity. By this method, we can know whether the elasticity is equal to 1 or greater than the 1 or less than the 1. But we are not getting exactly.
Yeah.
Hence, this method is restrictive or provides only a rough measure of elasticity. Got it up to this properly?
Yes.
Okay. Now we'll start with the degree of price elasticity of demand. So when price of different commodity changes, the quantity demanded of each commodity reacts in different manners. How? Demand of medicine or needles respond very less to the change in price as compared to AC or TV smart. There is no relations of the AC and TV
Yeah.
with the needles and medicines. That is what is called as degree of price elasticity of demand. So degree responsiveness of quantity demanded to change in the price may differ, and hence elasticity of demand could also differ. Elasticity differ because commodity other goods are differ, right? Medicines and needles are, it's related with each other, but there is no correlation with the ACs and TVs, right? So price
Yeah.
elasticity of demand can be expressed in terms of numerical values, which ranges from 0 to infinity. Right? Let's discuss, understand with the one by one. A price elastic demand, it means what? When there is an infinite demand at a particular price and demand becomes zero with a slight rise in the price change, prices. Then demand for such a commodity is said to be perfectly elastic. Now let's say understand. Look, when price was 30, demand was 100. Price was 30, demand for 200. Price was 30, demand for 300. It means what? Your price was remain same, but quantity demanded is increasing or decreasing. When your price was 30, your demand for 100. When price was 30, right? Your demand was 200, again 300, right? So it means what?
Yeah.
As seen in the schedule, quantity demanded can be 100 units, 200 units, 300 units, and so on at that same price. So we can understand price will be the remain same. So, but your quantity of the demand is changed. That is called as perfectly elastic demand. That is called as perfectly elastic demand. Got it?
Yeah.
Then, what is the meaning of perfectly inelastic demand? When there is no change in demand with change in the price. Your demand is remains same, but price is changing. Vice versa of this earlier case, right? Your demand was 100, remains 100, but your price was changing 20, 30, 40. But your demand is, completely constant. That is why perfect elastic demand is equal to ED is equal to 0. It must be noted that perfect inelastic demand is an imaginary situations only. It could not be possible
Yeah.
every time.
Okay.
And then highly elastic demand. When price, percentage change in the quantity demanded is more than the percentage change in the price, then demand for such commodity is said to be highly elastic. Let's see, understand. When price was 20, demand for 100, highly changing in demand, highly elastic. When price fall down from 20 to 10, it demanded 200 units, highly changed. When this is O-axis, X-axis, Y-axis, it denotes price, it denotes quantity. So when your price was 20, your demand was 100. When your price fall down 10, so demand is increased. So ED is equal, greater than 1. ED greater than 1, right? Now then,
Yeah.
it's a vice versa, this one. Less elastic demand. Completely vice versa, right? When price was 20, demand was 100. When price fall down 10, it slightly change in the quantity demanded, not highly, right? That is called as less elastic demand. So ED less than 1.
Mm.
Now fifth one, unitary elastic demand. When percentage change in the quantity demanded is equal to percentage change in the price, right? So in this case, ED is equal to 1 again, right? When price was this price, your quantity demanded was this, but when price fall down, so slightly your price is changed, quantity is changed. So ED is equal to 1. It denotes like this, right?
Yeah.
That is called as unitary elastic demand. So we can keep in mind, in a quick revision. So all these are the important terms you can keep in mind for the quick revision.
Yeah.
Got it up to this? Is there any doubt?
No.
So now, flatter curve, the curve more is elastic. Let's see, understand, how it works. When two demand curves intersect each other, then flatter curve is more elastic at the point of, intersections. So I think so. This is the flatter point. Am I right? Let's say
Yeah.
understand. Demand curve, that is DD. Here is DD. Here is DD. Right? Flat, that is called as flatter curve. DD1, that is steeper curve. DD1, that is called as steeper curve. Right? Intersect each other. Here, this is the point. That is where, on that point they are intersect with each other. Right? So point E, at this point OQ, that is the point, is demanded at the O price of OP, that is the OP price. When price rises from OP to OP1, here is OP1, OP1, right? The quantity demanded falls from OQ to OQ2. Now here is only, right? Then
Yeah.
for demand curve DD and from OQ to OQ1 for demand C. I hope you understood up to this. I'll
Yeah.
explain once again. Huh. First of all, I'll explain one point. DD curve that is this line, right? This curve is called as flatter curve, and DD1, this called as steeper curve, and both curve are intersect here only, right? So that
Yeah.
point is called as E point. That point is called as E point, right? Then at this point OQ, at this point quantity is demanded at the price of OP, right? When price rises from OP to OP1, when price is raised from OP to OP1, the quantity demanded falls from OQ to OQ2. Got it?
Yeah.
For demand curve DD and from the OQ to OQ1, OQ to OQ1 for DD curve. So that is the curve, demand curve, right? So with the same change in the price, PP1, change in the demand OQ2, this curve is called as DD curve, right? So this curve is called as flatter the curve, as well as you can say steeper the curve. I hope you understood up to this properly.
Yeah.
I think so. This will be enough for this today.
Yeah.
Enough or want to again take. Face is yours.
We can start next class, the rest of it.
No problem. Yeah, up to this, up to the next class, you can revise it properly. If is
Yeah.
in doubt, then you can ask me again.
Okay.
Okay, see you again. Bye.
Okay, thank you.